D2DNY, Real World HVAC Simplified. And now, in this video, I'm on a service call with another Trane RTU unit. And this one here, service call, is going to be on Epic One. All right. So this is for my subscribers or my fans, my followers. So this is what the machine shows. External stop. All right. So I'm going to delve into the troubleshooting, let you guys see exactly what the solution is and the resolution is. Get this bad boy up and running, back in line. But before we do that, if you have not subscribed, I want you to do so right now. Hit that subscribe button and smash the bell icon, so when I upload videos like these, you'll get them right away. All right. So the reason why this is a bit of a, I'll say epic, because this situation here, external stop, it may not have anything to do with actually the input on the terminal block down there. That's for external stop. All right. So pay attention. First, what we're going to do, we're going to find those points for external stops on the schematic, and then we're going to troubleshoot our way backward. So stay tuned. Okay. And this video is going to be rather short, 10 minutes or less, promise. So here is that external stop, right? And that goes across and it goes to 1 TB4, 17 and 18. So from the factory, there's a jumper across that. There's a shunt across that from the factory, out of the box, as shipped from the manufacturer. That's what it means, right? There's a jumper across that. Now, if you want to shut this unit down remote, you remove the jumper and put your dry contacts in between there, whether it be a relay, toggle switch, whatever you want to do. You know, you open this point right here, TB 1 TB 417 and 1 TB 418. If you open that point, the machine goes to external stop. Now let's go over there and check that and see the status of that point. All right, so here's 1 TB 14, 1 TB 4 rather, is right here. So we can zoom in on that. So right here, it's 1 TB 4. As you can see that, and we're looking at 17 and 18, which is right here. So the factory jumper has been removed, and there's two wires connected to this. As you can see, there's a white wire goes to 18, the black wire goes to 17. If these 2 points is open, or if these two wires, they have to go back to a dry contact. You know, like that is like a relay contact or a switch, and if that is open, the machine shows external stop. So we're going to go ahead and test to see if there's potential across those two terminals. If there's any potential, that means that remote switch or relay is open. So I'm gonna go ahead and put my meter on the DC, because that is DC 24 volts, not mistaken, and we're going to go ahead and test that. Stay tuned. Alright, so I'm in DC, and I think that's what it is. It's DC volts, and I'm gonna go across them. 17 and 18. I got 0. So either those points is currently closed, or there's no potential on the terminal. And let me go ahead and check for potential. I'm gonna go to ground. chassis ground, nothing. We'll go to 17 and chassis ground, nothing. All right, so you know, next step, I thought I'll read something if that was open, but I'm gonna go ahead and just remove those two wires that's connected to it and check that these wires in fact are not open, they're closed. Now if that's the case where these two wires are closed, I'm getting continuity, so I know that I have to move to the next phase of the troubleshooting, because that's not the issue. The external stop points right here is good. So let's go ahead and remove these one of these wires and check them for continuity to see if they're closed. Stay tuned. Take it out gently because I still have power and I don't want to create any short circuit. Got this wire off of 17. Now I'm going to go ahead and check for continuity. Put my meter in the continuity scale. Yup, good to go. And how I'm going to do this with one hand, just give me a moment. I get some jumpers or alligator clips and I'll show you guys. Okay, so just for a helping hand, I use some alligator clips, and I got this on one wire right here, black wire, other side of my alligator clip on my test lead. So I got, my hands are free now. All right, let me zoom out. All right, see what's going on. All right, that's that. Okay, and I have one on my test leads. So I'm gonna go ahead and test the continuity on the other wire, which is 18. So we know that that's closed. All right, so we know that that's good. The issue is not the external stop points. No. If out of the box, usually these points right here came with a jumper like this one. See this one right here? A copper jumper. Out of the box from the factory, there was one like this across 17 and 18. Now if you open, once you remove it, like I said, it will go into external stop, but you can put whatever switch you want to control that. So in this case, there was in fact a switch hooked up to it, but that switch is closed. That is not the issue. So let's put this wire back and then back to the drawing board, schematic to continue. Now it appears something else is going on, because typically when you have an open switch, you know, you should have potential across it, and there was no potential on 17 and 18. But let's get back to the schematic, back to the drawing board, and we're gonna look at that external stop right here. Let me zoom in on my, no, I'm not, let me bring it back in right there. So we are here, right here, external stop, and we can see right here we got a couple of options here. We got a from the main controller, main board, splice right here. There could be a jumper, which, you know, just a plain wire, but also there's an optional 1U3. It's a phase monitor, and you know, it's a Y and Y out. And so if this phase monitor is installed, I'm assuming this wire right here, this jumper, won't be there. And obviously you can see the circuit comes around, goes through the factory jumper or your external switch, if you have it right here, and goes back around. If you have a phase monitor as an option, it will go through the phase monitor and back into your controller. So now the next thing to check is this right here, optional phase monitor. Let's go and see that. And that is up there. Right there. Wow, it's nine minutes already. All right, whatever. Real world, real time, real HVAC. If you want to see something, just keep on. Another few minutes we'll be through this. Stay tuned. So I'm at my phase monitor. As you could see right away, out the box, I could see a problem. I'm gonna give you guys a few seconds to see if you guys see the problem as well. All right, time is up. There's no light. There's a green light that says on. Right, so green light right here. And then there's a red light that says error or fault. So we got line 1, line 2, line 3 comes into the phase monitor. And we got right here, it's a 115 volts uncommon for the power supply. And then we got the Y and Y out, as we saw in the schematic previously. Rewind the video if you missed that part. So this right here is your contacts. I'm gonna go ahead and remove them and check that. But I think I found the problem already. The fact that there's no light on this, I think this is definitely the problem. Also, Trane, you know, I don't know why would they do that, because it's rather confusing. You arrive at the unit and there's an external stop. So I'm in continuity. I'm just gonna check the contacts on the phase monitor if they're closed. So I'm in external stop. I'm not looking to check phase monitor. All right, this should be a separate input. You have all these control boards right here. Why can't you have a separate input so that if my phase monitor is tripped or opened, or there's a problem with my phase monitor, I get a separate alarm? Come on, Trane. Yo, you know your unit costs mad money. Like this unit costs mad bread. It's expensive. All right, so I'm gonna go across the contacts right here, and I'm not getting any continuity, guys. It's not ringing out, which means that this is opened. Nothing. Come on, let's test lead. Yeah, so that's open. So which means that, let me go into DC. So the phase monitor is open, so that's the culprit. 99%. All right, so yeah, so be aware of that, guys. If you pull up to these units and you see external stops, you know, you might want to check your phase monitor as well. Okay, here it is. The wire, my test leads are in. I am on DC, and yep, I have potential. So there's potential across those two wires, which means that, you know, it needs to be passed for the circuit to be closed and the system to operate, or something will happen. And that's the switch that it goes to. So I'm gonna go ahead now and see now what's going on with my power over here for this phase monitor. I put these wires back. I don't want to get them crisscrossed, even though if you do get them crisscrossed, you can just look at the schematic and verify. And then Trane schematic is not really a user-friendly schematic. All right, so then I'm gonna pull those off, and I'm gonna check for power, which I pretty much sure there's no power. All right, I'm gonna go to AC. Boom, and there you go. All right, so with that, we gotta now figure out what's going on with my power supply to my phase monitor. All right, so we do have, you know, line 1, line 2, line 3 down here. That's a different story, but 115 volts is what's going to power this device for the controls. Okay, for the controls within this device. Okay, so let's go check that out, and then back to the schematic we go. Okay, so here's your phase monitor, 1U3, and that's a 3-phase right there, which we really don't care about right now because it's not in error or fault. It's just that it has no power. And here's I think these are the contacts that have them jumped out. I don't know why. Again, Trane is a bit weird. But here's the power supply. It goes into 1TB61 and 1TB612. And that's somewhere down here, because it says 58. So right here. So you see that 1TB6 was a 1 and 612. Clearly you could see just basically the 120 volts or 115 volt supply. that goes back to the phase monitor right here. All right, right here. But then there's a fuse right here, 1F7, comes off of this transformer right here. That's line voltage up top. I mean, it's all line voltage. There's like 460 volts up here. You got a fuse, you got this switch right here. If this switch is closed, also if this switch is open, guys, you're gonna end up getting external stop as well. All right, so that's 1S1 and 1F7, and this transformer, is there a tag on it? I don't know. Oh yeah, there's a tag. 1T1. So let's go check this fuse right here, which is most likely the culprit, and then this switch right here is, I'm sure it's on. Let's go double check that and grab my meter. I'm gonna get down off the ladder. All right, so if you like this video, give it a thumbs up. If you haven't subscribed, subscribe. So here is the fuse, 1F7, and here's the switch. As you can see, it's on. Let's remove this fuse right here. So here you go, a blown fuse, and you get an external stop, right? This is a 20 amp fuse. Let's go ahead and check it. Just checking my fuse. Continuity. All right. Yup. It's blown, guys. It's opened. So this right here is the problem. So I'm gonna go ahead, replace this fuse, and we're gonna see what's happening. Stay tuned. Love the sound of that beep. If you like that beep, if you love that beep, comment love that beep in the comment section. All right. Again, this is for my subscribers, my fans, my followers. You stay tuned to my channel, and you'll be elite with troubleshooting in service. I almost start charging you guys. I'm kidding. Just give my videos thumbs up. That's good enough. So let's go pop this fuse in. This is good. We're gonna see what happened. Yeah, here's that jumper that came on the terminal block. That is what it looks like. All right, so the fuse is in. I'm gonna go ahead and turn the switch back on, and then go see what's going on up top there. Switch is back on. My ladder over here. Get up there. And voila, it's in standby. All right, so we're gonna go ahead now and just see if the machine goes through standby and goes through startup, start cooling or heating, whatever mode, or economizer, whatever mode it wants to go into. We're gonna see if it startups and run. So wait for that. And now while we wait, I'm gonna give you guys a view, beautiful view of the Manhattan Bridge and the Brooklyn Bridge. And that's the Brooklyn Bridge right there, New York City, rush hour traffic. And further back, you see that one in the distance? That's the Manhattan Bridge. All right. Again, if you like this video, give it a thumbs up. If you haven't subscribed, subscribe. I do upload videos like these on a weekly basis. All right, real world, real time, real HVAC, simplified. You won't find this stuff anywhere else, guys. Facts. All right, so let's get back to the unit and see what we got. Okay, guys, so the unit is doing its thing. It's in morning warm-up. Supply fan is on, heating 100%, even though it's not morning. It's currently in the afternoon or even, but that's what it's doing. All right, now I'm gonna go ahead and monitor it some more, because I still don't know why. I think this is a transformer that the power comes from, this one right here. And I don't know why the fuse blew, but it seemed like right now it's all right. I'm just gonna watch it, monitor it and see if the cooling turns on, or I'm gonna do a service test mode on the cooling and just to make sure that there's no other issues. It was just a fluke, I don't know, perhaps fuse do get blown sometimes, then you replace them and then everything is alright. But as you can see, we're good. Alright, if you like this video, give it a thumbs up. If you have not subscribed, subscribe. I upload videos on a weekly basis. Still here? You're special. I don't know why these units always display this here. It's strange. And there. So I'm gonna go ahead and throw this into a cooling test mode, and just to make sure my fuse stayed intact. The video is 21 minutes right now, so I'm gonna go ahead and close this off while I'm gonna do a cooling test mode, right? I want to see 100% cooling, see if my fuse is gonna pop. And actually I might make a video on it and upload it, so look out for it. Leave in the comments if you want to see it. I'm gonna make a video. If I get enough people, if I have enough people commenting that they want to see me put this in service test for cooling, then I'll upload the video. Closing this video off right now.